Welcome to Taxonomy Online Mathematics. We are still on the topic simultaneous equation. We dealt with the elimination, substitution. Now we want to look at the Cramer's method of solving simultaneous equation. Now don't forget, this method is borrowed from matrices. So we need to have a review of some of the terms and the metric, which is what? Determinant. So determinant of 2 by 2. If I have A, B, C, D, if I'm asked to find the determinant is going to be the product of the leading diagonal. That is AD minus the product of the other diagonal, which is what? BC. So if you are going to find the determinant, we find the leading diagonal. So it means that we are going to write our simultaneous equation in form of a matrix. As in, we are going to take the coefficients to make it 5, 4, 2, 3, which is the same as what? 7, 4. We know this will give us 2 by 1 matrix and 2 by 2. Now, if we are going to find the determinant, it means 5 times 3 minus 4 times minus 2. That will be the determinant. Okay, so in doing that, we are going to be marrying the 2 by 1 matrix with this. So if I take this and take this, it means that I want to find the value of x, because these are the coefficients of x. So if I take 5, 4, 7, and 24, leaving this, it means I want to find the value of y, meaning these are the coefficients of what? Y. So these are the terminologies we are going to employ in that method, Cramer's method. Now, to find the value of x, if I want to find the value of x, it means I need to find determinant using the x over the actual determinant. In this case, if I'm looking at this is going to be writing the coefficient for me to have 2 by 2 matrix. I am looking for x, so I'll ignore all of this for x and start with this. So that is going to be 7, 24, then minus 2 and 3. That will be the matrix divided by the actual matrix without the 2 by 1. That is going to be 5, 4, minus 2, and 3. So we need to find this time for determinant. Determinant over the actual determinant of the coefficient of x and y. So we know this is going to be leading diagonal, and that will give us 21 minus the other diagonal, which will be minus 48, all divided by leading diagonal 15 minus the other diagonal, which is what? 8. So what do I get from here? This will become plus. So I'll have 69 over, that is going to be 20 what? 3. I believe 3 times this will give us that. It means your x value will be 3. The value of x will be 3. Now, if I want that of the y, looking for y, that will also mean the determinant of y over the actual determinant. So in this case, we are going to ignore the y values and pick these values. So in that case, I'll be having 5, 4, 7, 24 over the actual, which will be 5, 4, minus 2, and 3. Now, if you check carefully, you will see that negative 2, 3 is in line when I come to this place. 5, 4 is also in line when I'm looking for y. So how you pick your terms? You mean when I'm looking for x, ignoring this, I pick the right hand side before picking the y. The same way, if I want to pick for y, I pick this before picking this, so that if I am, this is the y I'm looking for, so the x values will be in line with each other. If I am looking for x, which is the x I'm having here, I have to make sure the y values are also in line. These are the y values, they are in line, so that you don't make mistakes in that. So what am I going to get if I multiply the leading diagonal? I think that will be 120. Yes, 120. So 120 minus 28 as per our numerator. Then if you multiply the leading diagonal, you will still get what? 15 minus what? 8. So I believe you are going to have 20 from here. So we are left with 8. So that will be 92 over this will also give us our 23, I guess. So since 2 is here, 4 times this is 12. 2 carry 1, 4 times this 8. So this will also give us what? 4. Meaning our x, y equals to, then the x is going to be 3 and what? 4. So if you get this, so this is going to be what? 3 and what? 4. Using the Cramer's rule, you can use elimination, you can use substitution, you can use what? Cramer's what? Rule or system of what? 2 by 2 matrix. So in this case, we know this follow the format of what? Matrices, 2 by 2 matrix. We can also have a direct approach. Let me clean. But the direct approach, if I want to find x, it means x is going to be equals to, we are going to do cross multiplication. So I'm going to hold the x down, use this, minus 2 times 24 will be minus 80, no, minus 48, minus, that's the leading diagonal. Then the other diagonal will be 21 over, then I'll come back to the actual matrix. So this time this will be minus 8. Then this, you see here, I didn't go for the leading diagonal. I go for the other diagonal before the leading. So this minus 8 minus what? 15. I believe we are going to have our negative 69, negative 23. So that will still give us what? 3. So we can do the same to get our y, or I'll only substitute the y, the x into this place to be 5, 3, 2y equals what? 7. So in this case, I have 15, 2y, 7. Subtract 15 from both sides. 7 minus what? 15. So you have minus 2y equals what? Minus 8. So we are going to divide through by negative 2 minus 8 over what? Negative 2. So y will still give you what? 4 for a simple step. If you don't want to use the approach of the dx over d for x, then dy over d for y, you can still go direct this way to get your answer. I believe you have learned a thing or two. Take any simultaneous equation question, try this on it and see if you can get the answer. Hit me up in the comment section if you have any suggestion. Thank you for watching. If you are new, subscribe, like the video, and share with your learning colleagues. Bye bye.